Hello students, you are welcome in my lecture session. Today in this lecture session I am going to explain you about Gauss's theorem and its application. When we start this lesson, we should know about what is electric flux. Electric flux means when electric force lines penetrate, when electric force lines go across any surface, then an electric flux is linked with it. This is the basic concept of electric flux. As in the shown figure, electric force lines are going across a given plane surface PQRS. Here is shown area vector A and electric field vector E. Theta be the angle between them. Then electric flux can be given as the dot product of electric field vector and area vector, which is shown as here phi is equal to Ea cos theta. Obviously, its unit may be given as kilogram meter cube per centimeter cube per ampere. You can get it from the formula. In the similarly, you can write the dimension of uh, electric flux as mentioned here ml3 t minus 3 a minus 1. Electric flux is a scalar quantity. It is a physical quantity and this is scalar quantity. Similarly, uh, in the magnetic field, there will be magnetic flux. If you are if you understand electric flux, then it is very easy to understand the magnetic flux. Similarly, the magnetic flux can be understood. Now, next thing, small electric flux. Small electric flux may be shown by d phi e. D, uh, uh, d, d phi e in the calculus language when the electric force lines are passing through a small area, a small part of any surface. ds, here is shown ds. ds is the small area of small part on the surface and electric field. The angle between them is theta. Then the small electric flux may be shown by d phi e is equal to E dot ds. Now next concept is solid angle. You know very well about the plane angle. What happens in plane angle? In plane angle, we take length of arc upon radius. In the similar way, solid angle is actually three-dimensional angle. Suppose sphere is shown here and there is a part of surface having small area ds and its radius is capital letter in capital letter R. Then small angle d omega is equal to small area upon radius square ds upon R square and its unit is steradian. If you want to get the whole solid angle around a point, then you will take the whole area of the sphere. And you know very well the whole area of the sphere be 4 pi r square. When you divide it by r square, then you will get the whole solid angle around the point O, which is 4 pi steradian. Now this whole solid angle can also be expressed in terms of closed integration. Here is the symbol shown here. This is the symbol for closed integration. Integration comes under the calculus. It is the a branch of mathematics, calculus, where we uh, study about the differentiation and integration. So, if small solid angle is integrated throughout the closed surface, then it will be 4 pi stereo. Now Gaussian surface. Gaussian surface, there are different kind of Gaussian surface. A closed symmetrical imaginary surface of any shape is called Gaussian surface. Gaussian surface may be of the shape of spherical, in the shape of cubical or cylindrical, etc. etc. Now we are in position to understand the Gauss's theorem. Gauss's theorem is the fundamental basic law of electrostat. It is the backbone of the electrostat. Without the Gauss's theorem, the electrostat is incomplete. So now what is the Gauss's theorem? In brief, for a closed Gaussian surface, net electric flux or surface integration of the electric flux is equal to 1 upon epsilon naught times of charge enclosed in it. Mathematically, it is expressed or it is given by phi e is equal to surface integration of vector e dot ds, and this is showing closed integration, and which is equal to q upon epsilon naught. It means it shows that according to Gauss's law, the whole electric flux through a closed surface is equivalent to q upon epsilon naught. It depending upon the magnitude of charge which is existing inside the surface. Now this theorem can easily prove. You can prove this theorem very easily. Let us consider a closed surface which is shown right here. See in the screen, and Q be the point charge which is existing inside the closed surface at point O. Now let us consider a point P. Around this point P there is a small part of surface having surface area ds. Vectorially it has been shown here, and vector E. Theta be the angle between the small area ds, vector ds, and vector E. Now the flux, the small flux through this small area can be given by d phi is equal to E dot ds by definition, and here d omega is equal to ds cos theta upon r square. Again, look at here in the figure, ds cos theta, this is the surface area upon r square. It will show the small angle subtended by this small part of surface, which is given by d omega. Now, but you know, electric field due to a point charge, which is given by 1 upon 4 pi epsilon naught q upon r square. Now, put this value in the equation first. Now, what we get? Yes, look at here. Phi e is equal to vector E dot ds. Phi e is equal to E dot ds cos theta. In the next step, we will substitute here in place of E 1 upon 4 pi epsilon naught q upon r square. This is the electric field intensity dot ds cos theta. All the constant quantities will come out from the integration. Now outside we are taking here q upon 4 pi epsilon naught, very simple, and inside the integration ds cos theta remaining there ds cos theta upon r square. But you know that ds cos theta upon r square is small solid angle d omega. Now integrating this small angle d omega, you will get the whole solid angle around the point P, which is 4 pi. Now finally what comes? 4 pi will be cancelled by 4 pi, which is in numerator and denominator. Now finally the answer will come here, phi is equal to q upon epsilon. In this way, the Gauss's theorem has been proved. Let us summarize in this video session. uh, we are trying to understand what are the basic concepts which are uh, essential to understand the Gauss system. The first thing is electric flux. Second thing is solid angle. And third thing is Gaussian surface. After knowing these three concepts, we can understand very easily Gauss theorem. Thank you.